Hello. So today we will be looking at a machine learning problem which is Bangalore housing price prediction. So I will be solving this code live in front of you. You too can follow it with me. So I am sure it will be a great learning opportunity for you. So let us begin with the code. This code will be solving on Google Colab. So first of all we will open our Google Drive. And let us go to the path where we want to save it. See, I have already made this program. This here. Already I have made it. I will be doing this program again in front of you. First of all, we will make a Google Colab file. Create and share. After I am done with this coding, I will share with you this Google Drive link so that you can have the access to the notebook as well as the dataset. This here is my dataset. It is a CSV file. Let us rename our file Bangalore Housing Price Prediction. Okay. So we will start by first importing our libraries. Import pandas as pd, import numpy as np. So we are importing pandas and numpy. We will be using this. We will also import matplotlib. Import matplotlib.pyplot as plt and import seaborn as SNS. The rest of the other libraries we will be importing them as we needed, as required. Now our next job is to read the dataset. So for that we will use df equal to pd.read_csv, and now we have to paste the path of the file. To paste the path, first of all we have to mount our Google Drive so that the Google Colab can read that data file from the Google Drive. So click here. It will start the mounting of the Google Drive. Give the permission. Okay, so our mounting is now complete. Now we will go here into the drive. We will go on my drive. We will navigate to the place where our file has been stored. I have stored it here in AIML programs. This is the Bangalore housing price prediction. Let us see which one is my CSV file. Okay, so copy the path. Here put double quotes and paste it. Our file has been read. We can check whether it has come in or not. df.head will give us the top 5 readings of our data frame. So we get an idea about what kind of data we will be handling here. We have area type, availability, location, size, society, total square feet, bath, balcony and price. Price is my target variable. It is a regression problem wherein I have to predict the price of the house in Bangalore. We will be facing different challenges. We will see how to handle them. So let us begin with, let us see the info. df.info. So we get an idea that okay, most of our data are object type and 3 are float type. Okay. Next we will see the size of it. So df.shape. So we are having 13,320 entries and total 9 columns. Out of this, one of this is a target variable, which is the price. Okay, now let us move ahead. First of all, we will see we have to do many things. We have to handle the missing values, we have to handle the categorical values. So according to the situation, according to the domain expertise, domain knowledge and the required situation, we take decisions. Let us begin with the availability. Let us check how many different kind of values are there in availability. So df of availability, I will directly copy so that I don't need to write the spelling. dot value underscore counts. See, I am having total 81 rows. And the data set, if you see, it is like ready to move. There are so many values, 10,000 values are there. The rest of the values, okay, it has given in a date, but it is not really giving any kind of important information. So a better way to encode would be like a ready to move, whether it is yes or no. Which date we are able to move, that is not really helping us into building the model. So we will convert the availability into two kind of values, whether it is ready to move or whether it is not ready to move. So let us see how we are going to do that. Simply we will say df of availability equals to np.where df of availability double equal ready to move, which means that wherever the value of df of availability, this value, wherever it is equal to ready to move, there I want it to replace by 1, else I want it to replace it by 0. Now we will execute it, pressing shift and enter will execute it. Okay, done. Now let us check it. df.head. We see that our availability column is now having zeros and ones here. Prior to this, it was one date was given, it was not available to move, and here it was ready to move. So we can see that the data is reflecting here. Let us check the value counts. df of availability dot value underscore counts. Okay, so we are having, there are 10,581 properties which are ready to move. Rest of them, they are not ready to move, means they will be handed over in some future time. In our case, availability column has been handled. But see, before doing this, it is important that we should have checked the null values also. Here, since it is if it is ready to move, it will be 1, else it will be 0. So even the null values, if had it there been any, it would have been converted to 0. Let us check it. See, availability is not having any null value. Now let us look at the next feature, which is our location. First of all, we will have a look at the different unique values that it is having. So df of location dot value underscore counts. We see that there are 1305 unique values. We cannot do one hot encoding in this. We cannot create the dummies. We will be facing the curse of dimensionality, 1300 features. Not at all a good idea. So in this case, what we are going to do, we realize that some of the locations, it is coming only one time. So the locations which are appearing very few times, we will be categorizing them as others. Say if some building is in Whitefield, then it is okay, there are many buildings in the Whitefield, so that might be significant. But Upshot layout, this one, Electronic City phase 1, all these are having just one houses. So we will together classify them as others. So for that, let us see how we will be doing that. The criteria that we are going to use, that if some location, it is coming less than 10 times, we will be categorizing it as others. So first of all, we need to have the counts of the location. This is the location counts. We need to save it in some place. So let us say location underscore counts equal to same thing, df of location dot value underscore counts. This we have it saved here. If you check the type of it, let us see what type it is. It will come out to be a series. We see that it is a series. It is not a data frame. So this is my index, this is the value. Now I would like to see. Now I want the locations which are having the count less than 10. And those are the ones which are the other locations. So other underscore locations, I'll make a new list. This will be having location underscore counts, the value where location underscore counts is less than 10. And wherever it is less than 10, I need the index value, because when we see here, this is in the index value here in this series. Count is the value. So I will put dot index also. Let me see. So these are the values we are having. Okay. So next step, we will be replacing the values. So df of location is equal to, we will replace the values. How we are going to replace? So df of location, simple. We are replacing in df.location. Okay, this is fine. What we are replacing? For in df.location, you replace these values, other locations, whatever values we are having here. These values, you replace it by others. Simple. We need to put it in double quotes. Let us execute it. We did not face any error. Now let us have a look at, first of all, let's see how the df.head looks like. Okay, no major change here. Now let us look at its value underscore count of df of location. So df of location dot value underscore counts see, number of rows has now reduced to 254, and the others, I have a new variable here by the name of others, which is 2780. That means whatever values here was coming single time in location. For example, if I am getting a value of Electronic City phase 1 in this column, it will be replaced by others. Same for all the values which are appearing less than 10 times in this location column. Now, when we look at it, even this is not really giving me a very good picture of it. If I do the dummies, I will have 254 features. Again, too many features. So in here, we are going to learn the concept of target encoding. Sorry. So what exactly we are doing in target encoding? Say we have a group of some entries, for example white field. We will select that group, and for that group we will see the target variable. Now say we have here white field, we have other thing Sarja Road, let us put as SR. Say this is having some values, and corresponding to each value we will be having price. So what we are going to do in this case, white field, we will group all the white field together. We will take the average value of the price, and we will replace the white field by this average value. This is called target encoding. Let us see how we are going to do it in our code. So, according to the individual locations, we need what is the mean price in that group of locations. So, let us make a folder, location, not folder, of data frame, mean price. First of all, we will take df of location. We shall group it. We shall group by location. I am sorry, I have made an error here. We have to use df dot group by. What we are grouping it by? This df we are grouping it by location. What quantity we are grouping? We want price. Price is my target. I think P is, let me see whether P is capital or small. Okay, P is small. Price. Now, by what criteria? So, I want the mean of it. So, I will write the mean here. Let us execute it. Here it should be mean. Let us see the location mean price. Let us have a look at our data, what has come. Okay, so this place, Devrachikklan, I am not sure how to pronounce it. This is having a mean price of 62.7. So all these values will be replaced by, this value will be replaced by this price. First block Jayanagar will be replaced by 207, wherever in our dataset it is present. Others will be replaced by 141.8. That way we have converted our categorical value into numerical value. So this is called target encoding. We will simply map this into our location. So df of location, let us put it in double quote, equals to df of location dot map, and we will simply pass this. We will simply pass this value. You might be getting a doubt what kind of data it is. Okay, let us have a look at it. Why keep the doubt? Type. We see that it is a series. So directly we are going to put this series here into the map. It will map our values. Let us execute it. Now let us have a look at our data frame. df.head. We see that the location values have been changed and it has been replaced by the mean values. Mean values of that particular group set. I hope you are enjoying up till now. Now we have to deal with size. Now this can be a little bit tricky. Let us see how to deal with it. First of all, as usual, we will see what kind of values we are facing here. So df of size dot value underscore counts. Again, we realize that there are so many different kind of values. There are different unique values. Now there is bedroom also, BHK also. In this format it is given. But we notice that there is a numerical value. Everyone is having one numerical value. So let us try to extract this numerical value. Because see, BHK and bedroom, basically it is giving the same idea. We need the numerical 43, 16 or 12. This thing we are requiring. For that we will use the string function. So we will use df of size dot str dot extract. Now what do we want to extract from here? We want the numerical values. So here in extract we will put double quote bracket /d plus. /d means numerical value and plus. Now we will also put as type int. Okay, there seems to be some error here. Let us remove this thing. See, it has worked. This is working. We will make the change into df of size itself. Basically, df of size equal to df of size means we are changing in that same column. This is done. Let us have a look at df of size, the values. Now, df of size dot value underscore counts. We realize that now it seems like a numerical value, but there is a catch. You remember I was trying to convert it into an integer. Why I was trying to do it? If you see df.info, the size will be still showing me as an object only, but I know that these are the numerical values. Since we have extracted it from a string value, it is still reading as a string. So that we need to convert as integer. Let us remove this. We'll check it later. This also not really required, just to keep the clean code clean. So df of size equals to df of size dot as type int. See, here we are facing the error. Why I am facing the error? Because I cannot convert the NA into integer. See, actually what had happened, I was having null values in this prior to this. Let me check for the null values. df of df dot is null dot sum. Size is having 16 null values. Now, since size is a categorical type of value, I will replace it by mode. Let me fill it. df dot fill na. df of size. df of size dot fill na. Now fill with what? The mode value of size. So df of size dot mode. Calculate the mode and use the first value of the mode. Make this change permanent. Done. Now we will see, let us see df.info. I have pressed 0. As expected, the value is still an object type. Now I will change it to int. So df of size is equals to df of size dot as type bracket int. Now let us see what happens. We have converted it into integer. It is successfully executed. Now I will check df.info. We see that size has been changed to integer type. Done here. Now we will move on to the next, society. When we see the null values, dot sum, we see that the society is having a lot of null values. Now, You realize when we had checked the size df.shape, there are 13,220 values. Out of that 5502 are missing in society, which is a huge amount. If we see 5502 upon 13320 into 100, it comes out to be 41. 41% of the data is missing from this feature. So we will just drop this feature. It is not really giving us too much information then. In that case, we will drop it. So df.drop, what we have to draw? Society. Society. Now it will search the axis. We have to specify the axis, and we have to mention that the change we want it to be permanent. So in place equals to true, not plus, rather equal to. It is done. Now let us have a look at our data frame again. Society is gone from here. Next, we will have a look at total square feet. When we saw the df.info prior to this too is an object type. Now, looking at the first few values, we feel that okay, it should have been a numerical type, but certainly there is something wrong with it. Let us see. We will see value underscore counts. So df of total square feet dot value underscore counts. Now we realize, see, actually when we see here, there are some non-numerical type of values present in this. Example 1200 to 1470. There will be others also. In this data frame, since only few rows are visible for us in this case, that is the reason we are not able to identify it. We have to handle it. So first of all, we will check how many numerical columns and how many non-numerical columns are there. So let us see how we check that. This becomes a kind of tricky. So for this, what we will do, whatever the numeric values are there, we will go through the list, we will check the list, and we will store it into a data frame or a series. Let us see. Is numeric. I have created a variable. So what will it be having? First of all, it has to go through the whole of data frame. Where is it is searching? It is searching a total square feet. Okay. We have to use the string function since it is a string. str dot. Here we have to use match. And now what it is going to match? For this we are having a code here. Let us see. /d plus bracket \dot \d plus question mark. Question mark means that it is an optional. So basically what we are saying, that you match it whether it is of this format. This format means a numerical number followed by a decimal number. Optional. It can be an optional. Either it is there or it is not there. And after that it is getting terminated. Dollar means termination. And in case if it is NA means if there is no value, then I want it false. Let us just mark it here for our understanding. /d plus, this means one or more digits. After that, bracket /d /d plus. This means optional decimal number. Please keep in mind, optional means there has to be a question mark also. When we are putting a question mark here, now it becomes an optional decimal mark. So this will be followed by this digit number, and the $sign means the end of the string. This means end of the string. So it will go through all of this, it will go through all the values and it will check it. If this is there, it will store it in isNumeric. Let us execute it. Done. Now let us see. isNumeric. First let's see what type it is. Type. And directly copy it here and paste it. We see that it is a series. Okay, done. Now, isNumeric dot value underscore counts. We realize that the true values are 13073 and the false values are 247, which means that only 247 values are non-numeric type. 13,000 values are of numeric type. In this case, see, there are ways to handle this non-numeric type. This can be handled. In this case, what we can do, we can take the average of it, 1200 plus 1470 upon 2. But since we are to make it simplify it, we are just learning it right now. We will just drop these values since it is small quantity. Had it been in a larger quantity, then it would not have been possible to drop it. Now when we are dropping this, our null values are also included here. Since NA was also taken as false, so that will also get dropped. Let us see how to drop it. Simply, we will say df equals to df of isNumeric. Wherever it is true, those values will come, and we will create a copy of it. There seems to be some problem. Simply, the problem is that I cannot put it in double quotes. So we are done with it. Let us see how our data looks now. df.info. We were looking at total square feet. Okay, so it is still an object type. Why is it still an object type? Again, it was when the string function had worked on it, it was a string object only. No, we have not changed it. So I would like to change it into float type. df of total square feet dot as type. Now see, the square feet value, there are some decimal values also. So I cannot use integer. I will have to use float. Okay, so it has converted successfully. I need to make this change permanent, so I need to put it here. Okay, so this is done. Now let me have a look at it again. When we will see the df.info. See, it has converted to float now. Everything has been converted into float. The area type is remaining. This is an object type. We'll see about that also. Now, see, bath and balcony will be having missing values also. We had noticed it last time. Okay, we'll check it again. Let us look at bath now. df dot is null dot sum. We are having 548 null values in balcony and 16 null values in bath. Let us see what kind of values bath is having. df of bath dot value underscore counts. It is having many values. When you look at it, it kind of feels that this bath cannot have bath, the value seems a bit outliers. It seems that we are having outliers here. Because frankly, even if there are too many rooms, having 40 bathrooms kind of feels Not possible and impractical. Same goes for 27. So here we can say that we can have a kind of domain knowledge is there. See, if more than 10 baths are there, then it might have been a wrong value. So these can be taken as outliers. In this case, first thing that we'll do, we'll cap the outliers. For example, whatever value is greater than 10, we will replace it by 10 only. Say, if 40 is given, we will replace it by 40. If 10. If 13 is there, again we will replace it by 10. How do we do that? Let us see. So df of baths equals to df of bath dot. We shall use lambda of x. In lambda, what happens? This x is our argument, and what we are going to do with our x, that we have to put here after the column. So lambda of x is the variable. Here we will put minimum. We will take minimum of x and 10. Simple. So when we are applying, see, it is not lambda, we have to apply also. What apply does? See, the purpose of apply is to apply. What it does, it applies the function, homemade function, to all the columns. Means custom made function to all the columns of the data frame. And lambda is a function. Lambda is a command, or you can say it is a way through which you can make anonymous function. It is kind of a function. So this function is being applied to all the columns in the data frame. All the rows in the column of the data frame. So if the value is 25, so what will be the minimum of 25 and 10? 10 is minimum. It will be replaced by 10. If the value is 9, so 9 is the minimum actual value, so it will be replaced by 9 only. 10 will not be replaced. So this we will apply. I am sure you have understood this concept. Now let us have a look at this thing. def of, I will just copy this code. Now, so 10 is having 33 values. Now there is one more thing. Now we had null values here. df dot, I remember seeing null values here. We were having 16 null values. This we will be replacing by the median value. df of bath dot fill na. What I want to fill it by? See, it is a categorical type of value only, right? So I can fill it by mode also, and I can fill it by median also. Here, since there were outliers present in my column, I will use median. df dot fill na. df of, here only I will calculate the median. df of bath dot median. Simple. This I will place as df of bath. You mean make the change on me only. Median, median. Okay, so null value of the bath is also handled. So basically this bath column has been handled now. We applied the lambda. We have handled the outliers here in this step. Here we have handled the missing values. Let us just have a look at our dataset. How does it look? Okay, kind of clean. Let me see df.info. Okay, all are float. Only this has to be handled. This I will see in last because it is the easiest. Okay. Now balcony. Balcony is having some missing values that we have to see. Let me remove this. df of balcony dot value underscore counts. So these are the values that we are having. Either it is 2, 1, 3 or 0. Okay, that is quite understandable. We will simply replace it by mode. Because if we take the mean, if we replace the missing values by mean, I might get a decimal values. Balcony doesn't really have decimal values. Either it will be 1, 2 or 3. So I will replace it by mode again. df of balcony dot fill na df of balcony dot mode. Calculate the mode, use the first value, use this value itself. Done. Now let us see the null values. Just one value in location is as a null value. See, in location I am having just one value as null. I will just drop it. I can drop it also, I can replace it also. But here in this case, since only one value will be dropped, one row will be dropped. So I am not really losing much information. Let us see how we can drop this. So df dot drop na. I have to mention the subset. What is the subset? Subset will be location. I have to mention the axis. Axis has to be 0 and in place equals to true. Done. Now again let us check it. We see that the null value is gone. The only thing remaining to be handled here is the area type. Let us see how we can do that. So df of, again we will see the value underscore counts means number of values, number of the unique values that we are having here. Value underscore counts. See, there are only super built up area, so built up area is this much, plot area and carpet area. When we try to think about it, the area type, which is super built up area, it is not really giving any information. It is just saying that how we are measuring the area of that plot. Means it is the plot area or the carpet area. It is not really giving any much information and not helping in the model building. So area type also can be dropped from our data frame, from our this data set. Again, you have to keep in mind that while dropping any feature or while keeping any feature, you need to have domain expertise. In this case, my understanding is that this column is not giving any information. So I will drop this column. So df of df dot drop. What I want to drop? I want to drop the area type. Where I want to drop? It is a column. So axis equals to 1 has to be specified because by default it is 0. And in place equals to true. Let us execute it. Done. Let's see our data frame now. We are having a very clean data set, relatively cleaner data set. These are our dependent variables, independent variables, and this is the dependent variable price, which is the target variable. So up until now we were cleaning our data set so that it can be used. Now we will move ahead with our machine learning. Now we will be proceeding into model building and algorithms. So first of all, we have to separate our target variable from the dependent variable. So we will be having our x and y. So x is df dot drop price. Simple. Which means we want all the features other than price. And what will be our y? This will be df of price. We will put x in capitals as it is a notation that is being followed all over the world. Price not found in axis. We have to specify the axis because by default it has taken it as 0. Now we have to split this into train and test set. So we will import from Scikit-learn dot model selection import train test split. So here we have to write x underscore train comma x underscore test comma y underscore train comma y underscore test equal to train test split. We have to give x, y. Now we have to specify the test size, test underscore size. This will be equal to, let us keep it at 30%, so 0.3, and random state we have to specify for repeatability. Let us keep it as 42. This is done. Now our next step, we will do scaling. As we can see our data here, see, size is in the range of 2, location is in the range of 48, 115. So I want to have it, see, total square feet is even larger value. So I want it on the same scale. Okay. So we will do the scaling. So for that, we will now import the libraries from Scikit-learn dot preprocessing import standard scaler. Make an object sc equal to standard scaler. Okay. So now what we have to do, we will fit and transform it on the training data, and we will fit it on the, and we'll just transform it on the test data. Let us see. So sc.fit underscore transform. I will put x underscore train. We will not be doing scaling on the train target variable. And sc.fit, transform x underscore test. So you see, only the training value has been used to calculate the coefficients, you can say, the parameters for transformation, and whatever the value has been calculated, that has been applied on the test dataset. We will execute it. Let us see if there is any error. Okay, it is done. A very important thing that has to be kept in the mind. Now this we have to store it somewhere, like we'll put it in x underscore train underscore scaled. Similarly, x underscore test underscore scaled equals to, let us execute it. Done. Now it is very important to note that, do you think, see, x underscore train was a data frame. Do you think it is still a data frame? Let us check it. Type. Nope, it has become an ND array. So this array has to be converted again into the data frame. That thing has to be kept into the mind. Generally we tend to miss this point. So x underscore scaled underscore df is equal to pd dot data frame. What we have to supply? X underscore scaled train underscore. Now here we have to give the columns also. So how will I give the columns? Let us see. Columns equals to, the previous x is still remaining with me, right? So I will use that, x dot columns. X has to be capital. X dot columns. The x data frame was there. Their columns I am using. Same thing I will do for test also. X underscore test underscore scaled underscore df. This is pd dot data frame. Let me use this. Again I have to specify the columns. It will be same as the tested training data. I am absolutely sure that you are able to follow it. Done. Let us have a look at our dataset now. Dot head. Okay, we have a very good now this. Same thing for test also. Dot head. Okay, so our scaling has been done. We have two data frames that has been scaled, means training and test data is scaled. The y which is the target variable, that is also there with us. So now we can go ahead with the model building. So here we will be using just for the demonstration purpose today, I will be showing it through two algorithms. One will be the linear regression and other will be the random forest regression or whatever. We will see it. So linear regression. First of all, from Scikit-learn.linear_model import linear regressor. Linear regression. Make an object LR equals to linear regression. There seems to be some mistake. Linear Scikit-learn.linear linear. Okay, linear_model. Okay, we are doing fine till here. Now we have to fit our data. So lr.fit. Now we have to train our model. So we will put train data and y_train, x and y. I am giving the features and here I am giving the target. I am telling the model by this is your input, this is your output. Now you modify your coefficients accordingly so that when I give you an unknown value, you are able to predict it. With this, my training is completed. Now see, this model has been trained, it is working, but I need to evaluate that model. So in regression problems, we have two metrics to evaluate it. One is mean squared error, other is R2 score. In this code, we will be using those two metrics to evaluate our model. Let us see how we are going to do that. From Scikit-learn.metrics import mean squared error, comma R2_score. Okay, this is completed. Now here, to evaluate the model, we will be making a function. This will make our life very easy. So def eval_model bracket the parameter. I will be giving the model object. Let us see how we can. So first of all, y_train_predict. Basically, when we are giving the train value, what is the prediction? What prediction I am getting? For that, I will use model.predict. What I am going to give? x_train. Same way for test value. Why I need for both train and test? To check for the overfitting and underfitting. Same way I will take it for test also. Here I will replace it by test. Fine till here. Now I have to calculate the RMSE value, that is root mean square value. So first for the test value, test_RMSE. What will be the value? np.sqrt. For what? For mean squared error. Between which values? Train value, actual value and the predicted value. So I have to give the predicted value and actual value. Y underscore train underscore simple. Y underscore train simple. I'll put it this side. This I have done for train. Let us test. I will do it after this. Similarly for a train test also, simply replace it by test. Okay, we are done here. This I am done with RMSE value, root mean square error. Same way I will do it for R2 score also. So train underscore R2 score. This will be R2 underscore score. Again I have to give this value. And for same way for the test, this will be R2 score. I have to give R2 score of what? This value. Now what we are going to do, I want to print them. Let us see. Print train RMSE and give me the train RMSE here. What is the train RMSE? This value. Similarly, I want test RMSE. Replace this also by test RMSE. This value. Put a black slash in so that it will be displayed in a cleaner way. That's all. Same thing we have to do it for R2 score also. R2 score test R2 score. How we are calculating? This is my train R2 score. This is my test R2 score. So this will give me the idea of the matrix. Now I also want to check for the underfitting and overfitting. Let me see how I can do that. Check for overfitting and underfitting. So what exactly is overfitting? Overfitting means that the model is performing very good on the test data, trained data, but it is not doing so well on the test data. Basically it has memorized the pattern of the test data, training data. It is not a generalized model. So if train underscore R2, train R2 score is greater than test R2 score by a huge difference, say plus 0.1, greater than 10% basically we are taking. In that case I will say print model is an overfitting. performing well on the trained data but not on test data. This is one scenario. Now else if, which we will put as elif. Now we will put the condition for underfitting. What happens in underfitting? My test data is more than training data. Basically not data, rather test accuracy is more than training accuracy, is greater than training accuracy, plus there is a difference of 10%. Then I will print model is underfitting. Poor performance on both datasets. And any other case, I will say print model is good. No overfitting or underfitting. So we took efforts. So there seems to be a mistake here. Okay, we took efforts here to make this big of a definition, that is the function. This will help us. See, now when I have to evaluate my model, I will simply call this function and I will tell the object LR. See, I got train RMSE, test RMSE, train R2 score, test R2 score. So model is good, no overfitting or underfitting, but the accuracy score is not, it is a good score, okay, R2 score. Now we will check it. The R2 score is a good value, 48. Now we will check for on a different model also. We have used linear regression. We will try it with random forest regressor also. So random forest from Scikit-learn.ensemble import random forest regressor rf equals to random forest regressor. Now fit rf dot fit. What we are fitting? Train scale underscore df. See, I have made a mistake here. I did not realize it at that time, but when I was putting the train data, I did so much hard work here. I had to do this one, no? I had to use this here. I have to use the scaled one. Let us see. Now my model becomes overfitting. Let me see what happens with the random. Say it is not good. The score is not so good. I will accept that. The score is not a good score. There seems to be some error. But yeah, for now we are practicing it. Just how to implement the code. So it will do. See, there will be one more mistake that I am doing here. When I am predicting here, I have to again use the scaled version, right? Here too, I have to use the scaled thing. See, when you are making the code, you are bound to make mistakes. With the mistakes only you will learn. So there is no shame in that. Okay, this is done. Y we have not disturbed. So no issue with the y, only wherever we are using x, There we have to be careful. Okay, so we got it. Model is good. See what a mistake I had done at that time. The scaled version I have used here. So scaled version is giving a good value. See here. I have done the scaling. Okay, that is good. Now we will see with this. Train scaled value, and I have to put y_train so that it is able to train it. Let me see if it is able to train. It will take some time. Done. Simply we can do model_eval. Simply I will call the function and I will pass my model rf. Now you see the amount of hard work that we did, how it is helping us. Model_eval is not defined. Why it is not defined? Because this is defined, my mistake. See here, through this I am getting training value, training R2 score. It is 93, very good. But test, not at all, 53%. So here we see that the model is overfitting, performing well on the trained data but not on the test data. So this was an example of how we have implemented. We learned a lot of things. We saw a very different things. We found many different challenges. We learned about target encoder. We saw how a dataset has to be cleaned. How we made a function also here. How we were able to use the function. So I am sure you got to learn many things here. The video has been long, but I am definitely sure you will get some input from this program. Do let me know your views, reviews, if any error, any mistake if you spot, let me know about that also. And if you are do let me know in the comments. Thank you very much.